Thank you very much for joining us today. And we are here for the Google for Government webinar. And today we'll be focusing specifically on solving problems with Google Maps platform, which has been around for years, but has really grown in popularity amongst government entities. Within that realm, we'll be showing some logistics and routing examples today that can hopefully apply to many different use cases amongst the audience. We'll be showing examples from many different levels of government as well in this webinar, and also to let you know, at AppGeo, we are one of Google's top Maps partners, but we also carry a location-based services credential in regards to application development. So next year, it will also mark 30 years of experience with working with government organizations. So we're also super excited about that, and we can jump right in. We do also want to note that this is a webinar series, so feel free to head over to appgeo.com as well, and you can see our event section /webinars in this case. I do want to take a few seconds to introduce our speakers today, and we do have David Holmes first from AppGeo. And David is a customer engineer here with years of experience in GIS and in location intelligence. David is focused on exploring the use cases of Google Maps with our clients to solve location business challenges or location-based business challenges. And next we have Aaron Doucette from AppGeo. Aaron is an experienced GIS analyst with a web cartography focus and is dedicated to community adoption of geospatial tools for solving real-world problems. So one more reminder before we get started about the Q&A session at the end. Do keep those questions coming. And we'll have Dave kick us off after this agenda. So Dave?
Thank you, Jordan. Welcome everybody to our webinar today. We're going to, you can see our agenda up here. We're going to begin discussing some of the challenges that we've seen in logistics. We're going to take a look at the top 10 problems that we've come across and we're starting to address. Then we're going to take a look at how a combination of Google and us, Applied Geographics or AppGeo, can solve some of your logistic challenges. And in particular, we're going to answer the question, what makes Google different around logistics? And look at 6 ways to enable Google Maps technology through innovation from AppGeo. And my colleague, Aaron Doucette, will be showing us 3 real use cases of applications and demonstrations. And then I'll talk a little bit about getting started with Google Maps and how we can help get you going. So let's begin by considering what are the top 10 challenges that organizations face around logistics and routing technology. And I suspect that many of these may apply, some of these may apply to you, some, maybe all of these apply to you, but we have come to this list by talking with a lot of clients, by working in this area for quite a while with some experience, and it seems like it's a good way to frame up the problems that you may be faced around logistics. So number 1 is rising customer expectations. I suspect many of you are as amazed as I am that you can order something on Amazon on one day and it arrives the next day. Amazon really has changed the expectations around logistics in general. And that may be a challenge for you in your logistics operations, your fleet management operations, whatever. Of course, reducing fuel costs and time is always a concern, especially when you get into dealing with multiple vehicles, many stops, many deliveries, large numbers of passengers. The objective is around to save money and time. But to balance that, you also may be faced with managing labor cost and relations. So a lot of times, in addition to saving time and money, you've also got to balance your routes, balance your drivers, your use of vehicles across your fleet. And that may even be involved with some of the labor unions providing requirements around that topic. Customer service is always important to keep it as high as possible. In particular, well, first of all, customer service has a lot of connotations here. If you are in a delivery type of situation, you obviously have customers. But if you are running fleets for repair purposes, you have customers. If you're running fleets for inspection services, you have customers. And obviously, if you're running transit fleets, you have plenty of passenger customers. So this is not only, it's not only just about improving customer service, but also accommodating on-demand scheduling coming in some routing systems, as well as delivery time windows. Those need to be honored. So obviously, delivery locations may have time windows that you can show up in. Passenger transit systems have delivery time windows, so that is also very important. Traffic delays and wrong addresses are absolutely critical to performant logistic systems, and the ability to get real-time traffic and use that in your routing becomes critical. And of course, having a wrong address can slow everything down. So the having correct addresses, accurate addresses, ensures minimal wasted time. The world of passenger management has some fairly unique challenges, especially in scheduled transit systems, bus systems, trains, so forth, but also paratransit systems, as well as on-demand passenger transit systems. So this gets into the whole area of registering passengers, scheduling their pickups, scheduling their drop-offs, and of course you want to ensure that you are arriving on time and making that transit on time. Inventory management deals with what's on the vehicles. So you've got to deal with the challenges around vehicle capacities. I suspect many of you have fleets with different size vehicles, different size trucks. Or if you're dealing with repair or inspection services, you probably are concerned about, do I have the right tools on the truck that is being assigned for a particular route or set of stops that need to be made for repair purposes. And transit or logistic solutions often deal with high data volumes, whether it's lots of vehicles, many stops, lots of passengers. This quickly can turn into a big data challenge that you might be facing. In particular, if you are tracking or need to track real-time GPS points coming off of your vehicles and see those against a map to track your fleet, the data volumes go up. And of course, we're going to be talking about how to do this in scalable cloud architectures to address the big data problems. Next one is communications with drivers. Very important, especially if your routes are changing in real time during the day and you've got to get new instructions to your drivers. That becomes a critical element of a logistics solution. And likewise, when drivers run into conditions that they weren't expecting, an accident on the road or a road's closed for some reason, and they come back to they need to come back to the dispatcher or supervisor and say, you told me to go here, I can't get there, what do you want me to do now? So communications with drivers is very important. And then finally, managing fleet performance. I suspect that some of you are sometimes concerned about, are my drivers, are my vehicles, is my fleet working at optimal performance? Well, there are ways to measure that, pretty simple ways, where you can capture some key performance indicators, KPIs such as cost per mile, time per mile, revenue per mile, if that's relevant. And those things can be visualized, and you can quickly identify where maybe some of the lower than expectations on performance are happening and adjust your fleets accordingly. So this is what we consider to be top 10 challenges. I suspect some of these, maybe all of these, you can relate to. So let's now take a look at what Google Maps and Google Cloud, combined with AppGeo, us, bring to the table around solving some of these logistic challenges. So let's begin by asking the question, what makes Google different? Next slide, please. So Google has been very well invested for several years in the whole world of traffic and logistics, and continues that investment. The Android Auto product is collecting real-time data from Android devices in automobiles. The Waymo self-driving cars are using Google Maps for navigation. And probably everybody is familiar with the Waze technology. If you use the Google Maps consumer version, and you see the different colors of traffic conditions on the roadways, on the interstates and so forth, that's coming from a technology called Waze, which Google purchased a few years ago. So Google has been invested and continues investment in supporting the whole world of logistics. Next slide, please. course, Google is all about scalability. And as I mentioned, one of the challenges is this can turn into big data problems that Google handles quite well in their Google Cloud architecture. And with the amount of redundancy they have and the architecture they have put in place, problems can scale up with huge amounts of data, and you won't see performance degradation, and you'll absolutely see minimal downtime, if at all. Next slide. Probably one of the most important reasons to consider Google for a logistics solution, and for that matter, for other map-based solutions, is that the user experience is something that your user base is already very familiar with. Most people use Google Maps on a regular basis and are comfortable with the way the maps are presented. And of course, a logistics solution takes advantage of that user experience. And what that means is that you're reducing any training time on a solution built on Google Maps and quick user acceptance. Next slide, please. So just a quick overview on the Google Maps APIs. If you're not familiar with these, just briefly talk about these, and then we want to get into how these apply to solving logistic problems. So Google Maps APIs breaks into 3 categories. The Maps category is the API that you use to create static maps and dynamic maps on either websites or on mobile devices. Most people are working with the dynamic maps because that allows you to put your data as well as integrated with the Google base maps and stylize the data to fit the particular use case that you're achieving using the Google Maps technology. The Routes API is absolutely critical to logistics in that this is where you can use the APIs to bring back distances from A to Z. You can bring back directions, optimal directions, going from A to Z, points A to B with many waypoints in between. And if you're dealing with real-time GPS data coming from your fleet, those locations can be sent in and snapped against the Google Road network and displayed on a map, so you can get a real-time view of where your fleet operations are. And then finally, the Places API. This is tapping into Google's Places database, which represents 150 million plus locations around the world. And this is where the geocoding happens. So that's absolutely critical for accurate operations in logistics. Next slide, please. So you may be wondering who we are. We are AppGeo. As Jordan indicated, we've been in this space for many years, 29 years now. But fundamentally, we are a company that provides geospatial information technology innovation and solutions for people. And it's not just in logistics. We work in a whole bunch of many different market spaces, different verticals, anything really to do with location and geospatial data. We've been a Google Premier Partner since 2014. We are location-based services credentialed. So we have deep skill sets in both consulting as well as application development around the Google Maps and Google Cloud architectures. Next slide, please. So let's take a look at how we're going to combine the Google Maps technology with our innovative consulting and application development skills to address some of those challenges that we talked about in the world of logistics. And we've got 6 of these. So number 1 is Google fundamentally is providing a scalable cloud mapping platform, provides mapping routing technology along with their base maps to support logistics solutions. What do we do with that? We develop high performance applications for logistics solutions that combines your data, your organizational data, third-party data coming from potentially disparate systems, and builds out applications that scale with demand. Next slide, please. Now, number 2, Google is all about real-time traffic data. So the optimized routes that can be calculated can reflect real-time traffic conditions, and that is so important for accurate arrival times. That's using the Directions API out of the platform. And we take that and we provide user-intuitive visualizations of routes for assignments to drivers and vehicles, as well as driver directions or instructions. We can develop apps for real-time driver communications, that driver fleet interaction and management to fill out a logistics solutions. Next slide, please. Google is all about navigation and geocoding. As we mentioned, 150 million plus locations around the world constantly being updated to make sure they're accurate. And that is so important in providing accurate locations for logistics solutions. That's coming out of their Places database, as well as providing turn-by-turn navigation to allow drivers to conduct their routes. And then we take the geocoding results and the direction service to build applications that minimize wasted driving time, and help drivers get from point A to Z faster and safer. Next slide, please. Google is all about massive scalability. I mentioned this. With the Google Cloud Platform, they are ensuring uptime and performance, dealing with large traffic and data volumes on the Google Cloud. And we have expertise in designing, hosting, and supporting highly performant solutions on the Google Cloud with deep skills and experience. Next slide, please. Number 5, as I said, one of the most important reasons to consider Google Maps is that familiar experience. Provide that familiar user experience with Google Maps to increase user acceptance and minimize training to get people up and running on workflows. And we take that and we build creative, intuitive logistic workflows, which again combine the Google-based maps with your data, perhaps third-party data, to provide simple and productive user experiences around logistics. Next slide. Final one, optimal routing. Out of that optimal routing, Google provides the data required to support performance metrics, the distances along those routes, the time required to execute those routes. We can take that data and we can easily calculate some KPIs, key performance indicators, things like normalize all your routes over the last 6 months or the last year down to the cost per mile, the time per mile, the revenue per mile, and then visualize those routes. You show the KPIs through dashboards to allow you to help you quickly identify where the perhaps inefficiencies are. Maybe there's some issues around some of the drivers. Maybe there's some issues around when a particular vehicle or group of vehicles are used. Maybe there's issues around the particular time of day. Obviously, traffic plays into that. Or perhaps there's a particular geographic area. Every time you run a route through there, things slow down. That's the type of performance information that can be quickly identified and allow you to adjust your fleet operations to ensure that you're getting the most performance out of your resources. Next slide. So with that, I hope that's a nice, a quick overview of how Google plus AppGeo can be brought together to address some of your logistic challenges. So I'd like to turn this over to my colleague, Aaron Doucette, who's going to talk about a couple of applications that have been built with the Google Maps platform. Aaron?
Great, thanks, Dave. So today we're going to take a look at some of the applications developed by AppGeo that incorporate the Google Maps platform and also have a really strong routing and logistics focus. And I chose these for you today, especially since they are relevant to our government audience. And as I share these demos, I'd like you to ask yourself how the problems that we're looking at today, they might align with the problems in your own agency or municipality. I think what you'll discover is that the frameworks that we're presenting can really cover a lot of ground and fit a lot of different use cases that you might have within your own organization. The first demo we're going to look at today will be a transit management application, and it's really a larger story of complete system transformation going from paper into the cloud. The second story we'll look at is on our Bring Food application for home delivery. One of the key ways which AppGeo as a company has responded to helping people during this ongoing COVID-19 pandemic. And I'm really excited to share this with you today in particular, as you're among the first in the public to actually get a firsthand look at this application. But starting with the transit example, I wanted to take a moment to think about transit together. And depending on the size of your city or region, there may be a number of options available, or there may only be a few. But in almost every case, we have a cross-section that falls somewhere on this diagram. And I thought this was a really interesting way to think about transit. Regardless of where a particular system falls, there is always some way in which mapping technology can benefit the ridership. So whether it be estimating the arrival of a train, like we have here in Boston where I'm based, or a fixed route network of rail, or knowing how far away your Uber driver is from picking you up at your house, there's always something mappable and trackable because we're dealing with these moving assets. And today in particular, I'd like to look at a segment that actually overlaps into more than one category, and that's this kind of paratransit, demand responsive transit and busing service. Oftentimes these are run as private-public partnership, or there may be a regularly scheduled route with deviations, or in the case of paratransit, that schedule is changing every single day. And interestingly, transit service providers are relying on increased use of technology to improve the experience for both the riders and the operators, and also improve efficiencies on the management side as well. And these are often vehicles that, again, change their routes on a daily basis and accommodate specific needs. And by being able to rapidly make these changes to meet changing demands, we can improve that experience and also potentially save a lot of money on unnecessary driving and slowdowns. So all this might lead you to ask, how do we manage all that information between hundreds or thousands of pickup spots and destinations and drivers and vehicles? That's a lot to keep track of. How are people doing it? Which brings us to our first demo and kind of where we come in. So AppGeo, we worked with a transit company who's facing this exact problem. And specifically, they're responsible for the transportation of well over 11,000 passengers across dozens of cities and towns. And within their fleet, they have over 2,000 vehicles and even more drivers than that potentially, all on the payroll. So their journey started with a completely manual process where annually the dispatchers and the planners, they'd get together and essentially using a series of index cards have to figure out routes for each district, assign drivers and assign schedules. It was a grueling process and it was taking a lot of time. And as their organization grew, it became increasingly hard to manage. So they came to AppGeo a couple years back, and we took their whole process into the cloud by taking all of those pickup locations, driver details, their vehicles, along with all of their attributes, things like maintenance and storage lots, all of this in a relational database. And from here, we can use the power of the Google Maps platform to optimize the most efficient route from A to B with all of the pickups in between. And doing this while tapping into data like the real-time traffic and road closures to ensure that slowdowns are avoided wherever possible. You can imagine the last place you'd want to be is on a school bus full of middle school kids who are now late to their field trip because they decided to close a lane on the Long Island Expressway. This app helps avoid that situation by tapping into the Maps APIs. Specifically, we have the Maps JavaScript API providing the visual interface and the Directions API underneath doing that routing. And as a result, we have seen just in this kind of trial period, lower vehicle operating costs, minimizing delays, and really just a better experience for everyone involved. So with any routing application, you need to have a robust database of places of interest where you're actually routing to and from. In this case, we have a specific school district, for example, where we can tap into a particular town and get the exact schools that we may be delivering students or even supplies to through part of this service. And being able to filter and adjust information on the fly is very important. But again, we're working with a custom data set here, tracking attributes for all of these locations that then lives right on top of what you normally see through Google Maps. And additionally, this application helps them do all their payroll and can track vehicle performance, validating the arrival times against what Google thought the scheduled time would look like. That helps them over time improve their processes. So the next app we're going to look at today, I'm really excited to share with you all, and that is the Bring Food initiative developed by AppGeo just in the past couple of months. And when the COVID-19 pandemic first started really affecting communities, especially those around our offices in the Boston area and in Texas, our president, Richard Grady, really wanted to do something about it. And maps, as you all have undoubtedly seen, have played a really important role in the response. We've been kind of inundated almost with a flood of different trackers and heat maps and on the news every day showing us the spread of the virus and the case count and tracking metrics like that. But for our initial response, we wanted to do something that really had a strong connection to our own communities where AppGeo employees even live and work. So that said, around this very time, the pandemic was becoming very real. Food insecurity became a real issue for a significant number of people. Not only were more families than before facing economic hardship as a result of the virus, but food pantries themselves were facing the issue of not wanting to put people in harm's way to come get their nutrition. And you might think of food banks as like a large facility where a lot of food is coming in. Really, that's kind of like the Costco of the model, the business to business, whereas the pantries are often in a much smaller footprint building and is the actual kind of end location where people are picking up their food. And they're often run with the help of, or maybe entirely by volunteer staff. And what they realized was asking these vulnerable individuals to come in person suddenly became a problem due to the virus. The solution was a home grocery delivery model. But how do you spin up such a process overnight with limited resources? This isn't Amazon we're talking about. It's your local food pantry down the block that, might be run by a team of 5 or 6. So they found themselves in a hard position, and that's where AppGeo stepped in to help. So we created this Bring Food application, which takes in a list of addresses and optimizes the most efficient way to get to all of them, given a certain number of drivers or a maximum number of stops. And by leveraging Google as our technology for the geocoding and routing piece, we're able to take advantage of the most accurate and comprehensive data out there and take all the guesswork out of the equation. And this way, their network of staff and volunteers can spend more of their time actually helping people and less time messing around with data and trying to understand who is going to drive where. So this application, just to give you a little more context, is still in its early stages, but we've already gotten some great feedback from the towns that we've been beta testing with. One quote in particular that we heard on a call that really resonated with me is, what used to take us hours is now done in under 5 minutes. So, they're getting all that time back to really make a difference with people's lives and, bring food to more people. So I want to now dive in and actually show you how this is done in that under 5 minutes, ideally, and give you a live look at this application for the first time from scratch. So when we come into the Bring Food app, it's first going to ask us about ingesting data. And that can be like an Excel sheet or a CSV in this case. I've prepared some sample data with randomized locations for our demonstration today, just so you can see how it all works. So the first field we're going to look at is just assigning what these different columns mean to the application. So it knows that that's the city, that's the zip code, and this is what's being fed into that Google geocoder engine to take this, plot it on the map, and use it in our deliveries. Now you can see it's also brought in these additional fields. We don't have to assign anything to those, but when we finalize our output, what the drivers would actually take with them or even built into an application, they would know, exactly how many boxes they're dropping off and where they should be putting it. Pretty cool stuff. And as we hit assign here, it's doing the geocoding. This only takes about 3 seconds for our little batch here. But the cool thing about the Google geocoder, it can handle thousands or tens of thousands of addresses in a matter of minutes. And here we are with the map. So one thing that's pretty important that I want to share with you here is in any delivery application, which you can think of this as, quality control and avoiding errors is really important, because if you have an incorrect address or someplace in the wrong town, you're going to be spending an awful lot of time driving out there only to find you're in the wrong place. So in this example, let's say that we're doing deliveries only inside the Interstate 95 corridor here. We have 2 points that are outside of our delivery window that we can visually see on the map. I can quickly click on them and remove them from our current batch. We can also correct an address on the fly. So let's say, for example, I know this is actually supposed to be in the town of Medford and not Melrose. I can start typing here Medford, and Google geocoder has already picked up the rest. I can update it. Now it's in the right place. So here's our batch of locations. We've got about 30 of them. And this is where the Bring Food app really comes into its own. We can pick the maximum number of stops. In the future, we're going to add a whole bunch more variables here, but this is what we have to start with. And a distribution address, which is where all the deliveries will originate from. That would be like your warehouse. In this example, I'm going to pick this grocery store right here nearby. And Google, think about it. I didn't even have to put in the rest, but it's found the address right there. And I can now dial in. Let's say each volunteer is going to bring to 6 people's homes, optimize routes. And within seconds here, we will have our routes, each in a different color. They all start from the grocery store, and in the most efficient manner, using a proprietary algorithm we developed, it is assigning those deliveries. If we were to export this, you would get a list of, stop 1, 2, 3, the addresses. That could also be fed directly into an app for turn-by-turn navigation. Now, what's really cool, and where this has a lot of potential for other types of delivery, is not only are your stops changing on a daily basis, but so may be your driver capabilities. And let's say we go from having, a large truck to some smaller vehicles, or a particular vehicle is out of service that day. By changing these variables and re-optimizing on the fly, we now have a completely different set of routes that takes that into consideration. So here it looks like we brought it down to only 4 vehicles required if each is making up to 10 stops, finding the most efficient manner possible. So again, we're really excited about this application, where it's going, and we're happy to have partnered with Google on this effort to ensure that we can keep helping communities here as long as the pandemic is affecting communities across the country. We have one last demo for you today, and that's what we've done in Texas with the Drive Texas application that's run by their Texas DOT. And AppGeo has worked with this agency for a long time to build a statewide application completely native in the cloud. And what Drive Texas does is have all of the real-time tracking of roadway closures, traffic conditions, construction, and all of those important announcements. Oftentimes the kind of thing you might see on one of those orange dot signs as you're driving down the road. Now you can get it from your home too, or in a mobile application. And as Dave mentioned with the scalability factor, this actually came to be extremely important in something completely unexpected, which was the catastrophic Hurricane Harvey, which hit Texas in the late summer, early fall of 2017. And as you can see from this screen capture here from a news station at the time, the application was crucial in getting critical information on roadways that were affected by flooding out to a large number of people, and also display information on contraflow, or actual evacuation lanes for millions of people who had to evacuate. And this application went from a typical visitors of maybe a couple thousand every day to well over 1 million while the hurricane response was in effect. And lastly, you can see here how it's functioning on a normal day. We have those kind of real-time traffic layer coming in from Google. That's a different coloration you see. But in addition, as the video loops back through here, you'll see throughout the entire state, we can track accidents in real time as they've been reported, closures, construction, and a whole slew of other information. So think about this application as kind of like similar to Waze, but coming from an authoritative data source, the DOT for that state, rather than crowdsourcing. And what's really cool is we can tap into not only what the current conditions are, but what the future conditions are. As the DOT knows where they're going to be doing construction. They put all that information into the app. We know when it's happening, where it's happening, what will be closed down, and what's really relevant here is we can bring that information into a routing context, understand future conditions for we have vehicles traveling across the state on this highway, but on this date we may plan a detour. Those are the type of things that can over time really save a lot of money potentially, and definitely help save you from some stress. So that wraps up our demos, and before we get into Q&A, I wanted to touch very briefly on how you can take your ideas and bring them to life in the same way that we've seen applications from this presentation come together. The first step is getting started on the Google Maps platform, and it's a whole lot easier to do when you work with a partner such as AppGeo. Having spent a long time serving government customers in particular, we can adapt the typical billing model that Google provides and adapt that to fit your actual needs from a procurement standpoint. From there, as a partner, we can work with you to help get a project created, enable and choose the right APIs and the combination of APIs, and provision a key, which is the key that actually lets you tap into all the data varieties that we looked at today. Now, when Google put this platform together 15 years ago now, it's often coming from kind of a developer-centric point of view. So what if your organization needs a bit more help getting started, or wants to take your existing applications, which may or may not use Google data, and take them to the next level? And that's where our Spatial IQ program for Google Maps come in. This is something that we have started brand new after working with Maps customers really closely for the past couple of years and really understanding what are the needs that people are facing as they get their project off the ground. So within the Spatial IQ program, we can provide our experience for optimizing your APIs. This can actually save you quite a bit of money in the aggregate, as there's different ways to implement these and get efficiencies out of the platform. And we'll also look with you on a regular basis as well as an ongoing basis of making sure you're getting the support you need. And additionally, we offer some custom development services on top of this if you have a really great idea but are lacking some of the human resources to get it up and running on your own infrastructure. So definitely get in touch with us if that's something that is appealing to you. And with that, I think we're ready for the Q&A. I'd first like to thank you all for attending out of your busy schedules, many people working from home or in alternate accommodations. I do invite you to check out our events page, as we have a whole lot more free webinars coming up even in the coming weeks, and some really exciting announcements coming up as well that we wouldn't want you to miss out on. So with that, I will hand it over to Jordan, who will moderate our Q&A session.
Thank you, Aaron. We do have the first questions that have come in. How fast does Google update streets? And Aaron, would you like to take that on?
Sure. So that question can actually be broken down a couple different ways, and from the perspective of on the map and the cartography that you're seeing, and the classification of a street, whether it's a dirt road or a main road. We have seen that come up as an issue in the more rural areas. One thing to know about Google is they're always, they're driving the country with the street view. A lot of their road classification data actually comes from that process, so it's continually expanding. But they do have a process as well for getting in touch if there are errors. As a partner, they also take our input seriously. But the second kind of half of that answer is that they're being updated instantaneously from the perspective of real-time traffic conditions and closures, which are being taken into account with that routing. So when it comes to what you see on the map, accuracy is very important to them, and that's why they, don't take changes lightly. But at the same time, it's a constantly evolving platform, just as the road network itself and our world is constantly evolving. And as one of the largest providers of this information out there, they have a very strong commitment to keeping it up to date. But
Excellent.
yeah.
And I hope that answers the question. We do have another one that has come in. And what's the difference between Esri's tools and Google Maps platform?
Sure, and this is one that we have heard a lot actually, as we're longtime Esri users as well as Google users, and we know many of our government customers, especially, are in some way or form on the Esri platform. I think the key differentiator, from my perspective, even having been a longtime Esri user in my career, um, comes into what you're getting with the real-time data and the power of working in a cloud native environment. So the first part of that is the places database, for example. With the Google geocoding API, we can throw added addresses which are, partially incomplete or have some weird misspelling, or just say, Pinky's Pizza Shop. And because it has an extensive places database behind it, it's going to match up with the right address and put you right where you need to be on the map. A traditional geocoder, whether it's through the census or through Esri, you often find that no matter what you do, you find locations that can't be mapped, or they're mapped in the incorrect location. And being so crucial to the services Google provides, that's an area that they've really invested in getting right and making it easy. You don't need to be a GIS expert to use it. So I'd say that's one key differentiator there, just the quality of the APIs and what is actually backing them up. The second is that cloud interface that we've talked about. When you're working with Esri technology, oftentimes that's being hosted on your own infrastructure, which has limitations. You are running a government website, not all of YouTube, right? So your requirements are different. But with Google, they're tapping into those same servers to provide a very streamlined and fast experience. And what that means is it doesn't matter if 5 people are on your app or 500,000 people, it's going to perform the same. And we're aware of pretty much no other technology that has that level of scalability. So when it really matters, especially in these like disaster situations where going offline is not an option when people are evacuating a city, having a little loading bar that spins around for 20 minutes and then you restart your phone isn't an option. Those are the use cases where like we've really been committed to getting them into the cloud in the Google environment. So hopefully those kind of start to open your eyes. We like to think about it as not either or, but different use cases fit different technology. And at AppGeo, we're really confident in finding the right combination of technology and using the right tool for the job, which is why we're trying to introduce some of these maps platform concepts now to what may be a new audience for them. And any other follow-up questions on that, let us know and we can have a more detailed conversation.
There is a follow-up question on that, and I guess, want to jump on that. I will get back to the other question that has been asked, so you know who you are as well, but just to follow up, when updating information on the fly in Google, is it possible to bring that back into Esri?
Good question. So there's a couple ways to think about this. The information that's coming out of the Maps platform specifically can often have some proprietary nature to it. That said, you can use the Google Maps platform as a canvas to display your own data. And any data that you own, you can bring in or out, do as you need to. And that's in a lot of ways what Google does. To go back into Esri, there's a lot of ways to interpret that, such as, in a database it's living locally or maybe in their own, ArcGIS Online type infrastructure. So in many cases it can be done, but it kind of depends on the nature of the data and the terms of service that Google provides around what can be stored outside of the platform. But the short version is anything that Google generates, they like to live within their maps. But anything that you generate, such as like I have a GPS in my vehicle and I'm tracking it, that's under your ownership. So hopefully that helps. It's a little more of a
And we
complex
can
question than it seems.
and we can definitely like look more into that and get directly in touch with the question asker as well. I think that there's probably more to be said on that topic, and we'll just keep it, I think, moving along to the next question here. I think that was an excellent answer. How is Waze integrated into your platform? I'm assuming how is Waze integrated into the Google Maps platform? I know David touched on that earlier in the presentation, but who would like to take
Yeah,
that question on?
I'll take a first swing and then I'll pass it over to Dave for a couple more details. So an important thing to know about Waze, it started as its own company, as a startup, and the whole idea was to crowdsource things like traffic and potholes and police, even speed traps. And Google acquired them a while back and was in the background without really publicizing it too much, but taking all of the data that was reported from Waze and bringing it directly into the Maps application. So Waze was kind of their test bed community, and Google was the way to show the data. They now have some unique functions between the two apps, but in a lot of ways, think of them as the same data source. Google Maps also does its own kind of traffic calculations through their map now, but it is technically a Google product, but it kind of lives and works independently as a data collection platform. David, did you want to add anything to kind of that real-time traffic story?
No, I think you've got it. I think the key point there is that in the calculation of routes, the directions coming out of routes, in the API, you have an option to reflect real-time traffic conditions or not. And when you take that option in the API parameters, then they're tapping into the to the real-time traffic from Waze. I did want to comment on the earlier question. One other use case, Aaron, that might be relevant to the individual asking that question about can data go back into Esri? A real common use case is, especially in logistics, if you're sending out repair crews or inspection crews, and you have built a, perhaps you need a mobile app that provides those directions for them. So in addition to the routing, they're getting the turn-by-turn directions. Well, it could be that you want, when they get to that site and they do the work, you want them to provide some updates on the work, or maybe even provide some updates in an inspection app. That's all very possible in a Google-based app. Forms can be developed and configured, and that data can be captured. And of course, that data is owned by you as the organization. So that data could come from that app back into an Esri geodatabase. And there, as Aaron said, there are multiple ways for that to happen. So there's quite a bit of integration possibilities between a Google Maps-based application and an Esri-based application.
Absolutely. A lot of possibilities in that kind of collector concept.
Excellent. And we're going to move on to the next question now. If you upload data or photos into Google, can it be secured to be only accessed by your organization?
So absolutely. And the demonstrations we saw today, with the exception of Drive Texas, which anyone can get onto, those are both login secured. And Google takes data security very seriously, as does AppGeo. And in many cases, these are proprietary applications for your organization with sensitive data for employees or public safety, for example. And even though we're using a cloud-based storage mechanism, All of that can be credentialed very specifically for individual users, even different tiers of users. So you may have like a dispatcher level and a driver level and a user level and an admin level, all of which may need to be provisioned to see different things depending on their role. And that goes for photos as well. So again, I think separating a little bit what you've come to know as the consumer Google product, where everyone logs on, sees the same thing, and then these applications which are built on Google technology but are wholly their own application. That's a key difference, and something that is really at the core of what we're talking about today. Going to that level where you have something that's uniquely your own, with your own security, with your own controls. Any further comments on that one, Dave?
Just one thought is that when we build an application that is authenticated, we are taking advantage of the Google Cloud security capabilities, which is quite extensive. So it's very secure. Let's put it that way.
Absolutely.
Excellent. And I think that pretty much wraps up the Q&A. I want to thank everybody for their attentiveness and attendance today. And those questions were just absolutely fantastic. So thank you so much.
I'll add really quickly, Jordan. On our website, we do have available a quick PDF download that explains some of these APIs in more detail. And you can find that on appgeo.com. And we'll include it in the email as well with the recording, but it'll go a little bit deeper so that you can take away to help know which APIs kind of fit with which use case. Just a little plug for that PDF.
Great. And it is now approaching 3 o'clock Eastern time. So we do want to wish everybody a great rest of their afternoon, and we're going to wrap this session up now. But on behalf of AppGeo, I'd like to thank everybody again for attending, and we hope you do join us for more upcoming webinars.